In this video, we're going to study isosceles and equilateral triangles. So isosceles triangles has some quite interesting characteristics and properties. First of all, some vocabulary. First one is called legs. By legs, we mean these two sides. So the two congruent sides, so it will be AB and BC, right? These two are congruent. So those are called legs in the isosceles triangle. And then be careful here. The angle where the sides intersect is called the vertex angle, and that would be angle 1, or angle B in that matter. And next, the side opposite of the vertex angle is called the base. So it should be, well, use code. It should be the segment AC. That's what we call the base because it's the opposite of angle 1. So in terms of, in a triangle, angle and sides correspond to each other when they're opposite to each other. And lastly, the angles along the base are called base angles. So that's angle 2 and angle 3. Next, we're pretty familiar with isosceles triangle theorem, which states if two sides of a triangle are congruent, then the angles opposite those sides are congruent, meaning if in our example on top, if AB and BC are congruent, then angle A and angle C must be congruent. So it's translating the congruency in sides into congruency into of the two base angles. Now the converse, obviously you just need to switch the conclusion with the hypothesis, which is if angle A and angle C are congruent, then these two sides, AB and BC, are the two identical legs. They're congruent as well. Okay? So let's do some practices. Most times, these theorems are just here to help us establish certain connections and look for equations. Let's do number 3. In number 3, I have triangle XYZ. And notice that if I have two base angles at 77 degrees and they are congruent, which means the two sides, XY and YZ, must be congruent. And if XY is 12 centimeters, YZ must be 12 centimeters. And now in order to know the angle measure of Y, I have to use 180. That's the interior sum theorem. And I should have 26 degrees if you use your calculator. Okay? Next, let's look at number 5. Number 5, all there's given is these very valuable tick marks. That means this leg and this leg are congruent, which means this angle and this angle are base angles, and they must be congruent. Therefore, their angle measures, one is at 4x plus 7, the other one is 9x minus 33. They must equal each other. So through that thought process, you just converted a geometry problem into a very simple algebra problem. And if you do your math right, please check my numbers. X should come out to be 8. The rest of it are very much similar, so I'm not going to repeat myself. Make sure you pause the video and finish these pages. This one is a little bit more complicated, so let's look at number 8. In this case, I always graph this triangle out, and notice here which one and which one are congruent. So if I have an equilateral triangle or an isosceles triangle in this case, so it looks like the common point is T. So if I have T, RT and ST being congruent, then I would know these two angles must be congruent, right? So angle R is right here, and angle S is there, and angle T is on top. So I'm asked to find the X, so that should be pretty easy. That should be angle R. The measurement for that should equal angle S. So I should have, that should be 20, that should be 4x. X comes out to be 5. So if X is 5, in order to find R, I just need to sub it in. 9 times 5 is 45. So R should be 47. If R 47, S must be 47. And then if you can either substitute it with 17x plus 1, or you can just use 180 minus 47 minus 47. You should have 86 there. Okay, so that's how we handle this type of problems. These are not hard, but it's about reading it carefully, looking for the clues where you can establish these equations. So make sure you finish the rest of the practices. Now, in addition to isosceles triangles, we also have some practices for equilateral triangles. Recall, a triangle is called an equilateral triangle if and only if it is equiangular. In other words, all three angles must be congruent. And if all three angles are congruent, all three sides will be congruent. So it's also called the regular triangle. So in this example here, if angle measure ABC are all equal to each other, then all three sides must measure the same. They equal each other. And if the sides are equal, then their angle measure must equal 2. And this is an if and only if statement, which is biconditional. Okay. So some examples here. Let's go for number 11. I have, if I have 60 and 60 and 180 minus 260s, I would have another 60 degrees here. And therefore, all three sides must be all 9 feet. It's fairly simple and straightforward. And the last one, number 13, you've got 3 sides that's given, and you've got an angle that's given. So I think the easiest thing to do is you're asked to solve for x and y, but you're also given that they're equilateral. So it doesn't matter which side you use. I would do 9y plus 1. I like to take the smallest numbers possible to keep my life easy. And I should have 9y plus 24 equals 11y. So 24 should equal 2y, and y is 12. If y is 12, oops, sorry about that. If y is 12, then I need to go for the x. The x is in a way easier, in a way harder, because no information is given about the x, about the angles. But we know that all equilateral triangles all interior angles in a equilateral triangle are identical. They're all 60 degrees. So that's a simple algebra problem where x equals 9. Okay? So again, the trick for the x is hidden in this word, equilateral, that if you're given an equilateral triangle, you know each interior angle is measured at 60 degrees. All right, that's it, guys. I will see you soon. Bye-bye.